Dr. Bilo, we saw 3 specialists and we now need to integrate this into our finely engineered design. Which specialists did we talk to?
Precisely. We had a talk to Erwin ten Brinke, ABT, about structure design.
Structural design.
Alessandra Luna Navarro, our own expert for building physics and user comfort.
Building physics, and finally,
again, Erwin ten Brinke talk about additional aspects, as for instance, the assembly of the facade.
and burglary.
Burglary, precisely.
And what I'd like to do now is I'd like to take care of each comment they gave to us and get them into our final details.
It's the update version.
It's the updated version. And here we talked about the different systems, the aluminium, the timber and the steel system. And he was very clear saying steel is the most narrowest, aluminium a bit wider, and timber would be the largest. And he also defined, okay, if you go into the catalogs, identify the height, 4 meters in our case, you end up with a certain dimension, which we may have to integrate. So when we looked at the catalog, we ended up, okay, this is going to be 15 centimeter. Good.
150 millimeters, perfect.
Here we have a result, which is exactly what we wanted. We need this kind of feedback to identify what's the setup we are dealing with. Now, next, he didn't have any comments on the global geometry, also the
Neither on the grid, precisely.
fine for him. We discussed the tolerances. He was absolutely okay with our choices of giving it some tolerances. And then, this was an interesting one, identifying where do the loads find their way down. So down the loads from the doors, which is why we're going to have some kind of interlock here, which we see in a second. And then we discussed also the weight of certain facade components, which means that weight from here needs to be transported and then down in the system, which we're going to see in the detail, the main facade detail, in a second as a consequence. Here we go.
Well, that was an interesting one. Yeah.
Go on.
Yes, there's the glass in principle is taking its load on these little glass blocks. They're not visible in the section. And then it also defines how deep the transoms will be, or the mullions will be, to take deflection and deformation within that of the load of the glass.
And then interlock between horizontal and vertical components is again something which is solved within the system. So each system has a different kind of interlock, as we saw them in the previous videotapes from the system suppliers. That's mainly it. Okay, no direct comment here. Oh, this is upside down. Sorry for that. This was the top part. Interesting one. We discussed concrete may move versus facade being in position because of deformation of the building. We don't want the concrete giving its load to facade.
Erwin mentioned that it is dealt with in order to create a sort of telescopic connection. So the transom of the facade sticks out a little bit higher than the mullion.
Okay, I'll do that.
Or the mullion sticks out than the transom. I was keeping this. And then there is a point that is attached to the concrete on top that grabs into the transom and secures the facade to be not moving inside outside, but can actually allow movement from the beam on top or the opening of the building or something like that.
So we have, say, a certain dimension of tolerances being possibly here in this case, and then this is kind of double, as he named it, double situation.
Yeah, a dowel, precise. And this is a standing facade.
Yeah.
And then on top it's a flexible joint.
Top flexible joint brings us to bottom.
It's the same here. The mullion actually extends a little bit over the transom, and then there's a steel shoe or a bracket being fixed to the concrete floor, and that is then also secured permanently. There's no movement in this point. This is fixed. The facade stands on its feet on the concrete floor.
Yep.
Often in construction details they are dotted because they are only every now and then, let's say every meter or depending on the grid.
Yeah.
And later on we will also hear from the expert that there needs to be insulation in there.
This was the horizontal connection, so the horizontal, say, stick system, which has its horizontal lines here, which is then by the door, as we saw, delivering horizontal forces to this system. And he also was arguing that it's maybe necessary to secure that the facade itself is stiff versus the fixed to the outer wall. So we have some kind of, what kind of material are we going to take here?
Yeah, this is, I think, steel. I would, for instance, leave that open to the facade contractor. They have their own systems. They prefer those systems from the system suppliers. But in general, a metal, steel, L profile already does the job.
Does the job. Now it's in here, dotted again, because it's not going to happen continuously. It's going to be every meter. Again, we talked about the forces and the consequences of this one, and then fixed this facade too.
What was interesting is that he already mentioned, hey, take into account that often the door itself, with different parameters to be taken care of the glass, may become heavier than the insulating glass units left and right of it. So therefore, make sure that the mullions of the facade can handle these loads, and often they will be defining the overall dimension. So therefore, make sure you already know which doors have to be integrated and which functions they have to fulfill.
Which is what we did here.
Precisely.
And then we end with this detail. No additional comments from this expert. Brings us to building physics. Yeah. So we do the same round again. Building physics, that's an interesting one. So Alessandra evaluated our line of defenses, the inner one which is air tightness, the outer one which is rain tightness, and the middle one which is insulation.
She was quite happy because the system provider already takes care of that. That's a standard detail, and therefore Schüco, in this case, the system provider, took care of all of that already within the standard setting.
Grid, no additional comments. Tolerances, no comments from her side. Here we started talking about shading. We asked what kind of opportunities would we need to take in consideration for shading. The first one is having an outer shading system, which then creates enough shade for the facade itself. She explained the values. An inner shading system which has, say, less value, less potential to serve. But we also defined Northern Hemisphere project, north-oriented
facade. It's a north facade in this case. We don't need an exterior sunshade in here.
So we actually skip this complexity.
Yeah. But always make sure sun shading is a key part of the design of the building. And there's pros and cons for the various different systems. You have to make sure that you deal with that, otherwise you have problems later on with the climate concept. But it's not part of this lecture.
I finished with this detail. Here we again talked about the shading, and she also came with the opportunity of having some kind of coatings depending on position. So this is, say, if you cannot deal with a shading device inside, outside, movable or something, you may end up with a certain coating. But that's what she was talking in that interview about. Then we continued following the line of defenses. The inner one, correct. The outer one, correct. The red one, which is the one for securing thermal insulation as a setting. This was fine for her. She had no additional comments. Same for the bottom part. We had some discussion if you're going to fill this void or if we keep it open. We ended up in keeping it open, but you may also fill this void. But as this is the insulation, main insulation for the house, this is...
What was interesting is she already mentioned within our little sketches here of the details that brackets and systems that are provided by the system supplier in order to connect the facade to the building are already taken care of a good insulation. You can see this in these various chambers. It's a plastic material which has a sort of conductivity, but in this case it's perforated in order to make sure that it is as good insulating as possible.
No comments here. This was an interesting one when we were talking about acoustics for the facade. So we have this normal stick system as it is with an IGU with 2 layers of glass. And if this acoustic-wise needs to be improved, we can go for different thicknesses for the glass itself, or may even go for a triple IGU, which then also Temperature helps to improve the U value. When you look at the details as they are here, you see the size of the IGU. This could be a triple one. This is for sure 2 layers of an IGU. So that worked nicely. And then for the door details, no additional comments from her side because we actually follow the system. So building physics,
Done.
check.
Quite interesting how many factors you actually have to take care of. That should be integrated from the very first beginning in a description of the performances of the building.
As we are teachers, luckily we didn't get that much serious comments. Okay. Additional aspects, impact, construction at site, things like this. Again, Erwin, no comments to this, no comments to this, no comments to the general grid system. He did not have any difficulties with the tolerances. He was very happy. Us having already tolerances integrated, and now how do we get this really installed? This was an interesting one. We discussed how do we do this. So we have this opening, it's 4 meters high, no one will be able to get to the top part. You will need someone taking care of a certain height. Scaffolding system in front of it, directly the problem to get the glass units integrated. So he ended up in saying, Naya, a cherry picker, so a device which moves in front of it.
Could also be a scissor lift, for instance, that is movable. But what he also mentioned was take care of the installment of the facade profile itself, the system, the stick system, and then also think about how to attach the glass, because it's different activities that has to happen, and also for the glass installment, they come with the special mounting system with the suction cups to put it in place. Yeah, precisely.
Important to consider that you need to have space in front of the facade, and it needs to be solid enough to allow to have certain
accessibility, and the load-bearing field in front of the building often is still mud or something like that. Make sure
you have to do something.
Precisely.
Then horizontal impact. We took the next drawing to do so, which means you have a person who's somehow bouncing in the facade. This is defined with 100 kilo horizontal impact, normally taken care of by the system. So again, a topic to be considered when you decide the system and when you say go into the system descriptions, that you can identify that this is the load the system can actually accept. Next one.
That was an interesting.
That was an interesting one.
Burglary.
Burglary. How do you get into such a facade? You actually can break every facade all the time.
Yeah.
And we learned the main topic is to make it complicated.
So to delay the time people can break in.
So he came up with alternative fixing devices. So when we again look at, say, this system, and we remember there's a screw in here having different types of screws being positioned there, and if you don't want to break the glass, you may have laminated glass sheets which then are somehow maybe even fixed to the system, not in this detail, but they again, system suppliers deliver different qualities, different performances for.
Well, I was wondering, we haven't talked about that, but a student recently asked me, what if the facade isn't being able to strong enough, but you have to protect, for instance, is an embassy.
Yeah.
When someone drives into the building with a truck or wants to drive, how do you do that? Then you make a super, super, super heavy facade, or are there other ideas?
And at certain points there's a limit. Yeah. So you cannot solve this within the facade system. Yeah. So you have to find alternative solutions.
Like?
For example, concrete blocks, solid structure in front of walls, what kind of?
In front of the building.
In front of the building.
So you make sure that the truck can't reach the facade. Okay, but then it stops here at the facade, then it's the landscape architecture who has to take care of that.
That's absolutely correct. This is not our business in that respect. Yeah. We also did talk about bomb blasting. That's a different one. Here we want to have the facade being soft enough to, in case of explosion, taking the impact. We defined for this project, it's not next to being a no facade. It's not an embassy, so we're not going to take care of this kind of questions. Fire, another interesting one. We discussed about the fire situation. Normally in, say, low-rise buildings internationally, you can accept that there's a fire here, but you have to somehow take care that the fire not directly takes up. If it is a high rise, you may have to do some additional measures. Normally we say kind of a meter distance.
That's in the parapet, for instance, that is able to withstand
Concrete,
the fire.
whatever. It's an opportunity. If it's a bit more advanced, you may also do a sprinkler here to cool down the fire, to reduce that, which is say the fire outside. What about smoke?
That was interesting because imagine there's no fire at the facade, but in the office underneath, and there's a quick development of smoke that could actually find its way within these interfaces and connections into the other room above. You have to make sure that all the details are so closed and sealed that the smoke will not enter the building above or the room above.
Again, systems do give information on this topic, and if this is, say, for a specific type of building like high rises, you may have to go for a different system to secure this, or you may have to do additional, say, non-combustible materials being placed in here. Right. Bottom part, no specific comment from his side on, say, additional aspects. And side detail, nothing in specific. The door detail, we already talked about the loads to be taken, and the horizontal door detail, nothing in specific here. So by that, we close this chapter of engineers commenting to us and have to conclude. Now we have a set of designed and engineered facade with comments from our specialists being taken care of. The next step would be to get this somehow in a tender process, being able to ask companies which would be able to build, construction companies be able to build, to say bid on this.
Yeah.
Okay, here we stop.
Hey, perfect. Thanks.